In this example, we're given a graph, and we're specified three particular points: the ordered pair xy equals 3, 3, the ordered pair xy equals 0, 1, and the ordered pair xy equals -2, 0. And from that information, we're asked to find the graph of the inverse function, f inverse. So the thing you want to remember is what it means to be an inverse function. In this example, we see that our f function contains three specified points: the ordered pair -2, 0, 0, 1, and 3, 3. Now that's not all it contains. Those are just points that were emphasized in the graph. It contains every ordered pair on the graph of f, but those were three that were pointed out to us. So we know that if the original graph contains those ordered pairs, the inverse graph is going to contain the renaming of those, or swap the x's and y's and get the different ordered pairs. So the xy in f becomes the yx in f inverse. So you just switch the position of the x's and y's, and you come up with 3 points that will be in the graph of your new function, the function of f inverse. And that'll help us actually get in a situation where we can see basically what the picture is going to look like. So we draw our y-axis, and we draw our x-axis, make some marks, always make marks and some numbers that are needed. Well, we see that the ordered pair, let's see, which one should we put up here first? We have the ordered pair 0, -2, 1, 0, and 3, 3. Okay, so those are our three ordered pairs that we determined for sure lives on this graph, and then we're going to join them together and get a basic idea of what this picture looks like. Another thing you can remember when you're drawing the picture is that every time you graph a function and its inverse together on the same xy coordinate system, there's going to be a symmetry. And that symmetry is if you draw a diagonal line, which is the actual equation y equals x, through the origin, that diagonal line is going to cut the picture of the two graphs together exactly in half on both sides of that diagonal line. Now, I didn't demonstrate it in this example, but that is the case. Here we just took the original given picture of f, we took the ordered pairs, we flipped them around, and then we did the graph as best we could of the f inverse.